the sign will be +1 or -1. So basically, this is 2 arctan H, product from I equals 1 to L C minus 1 of Sn times the product of, sorry, let me back up for a second. Let's define L hat in as the magnitude of L in. And let's define S in as +1 if S in is greater than 0, -1 if S in is less than 0, and 0 if, L in is equal to 0. In other words, S in is the sign, but if the input is 0, then the sign is 0. This is sometimes this is a reasonably common definition of sign, that if the argument is 0, then the sign is 0. In that case, that reduces to this, because if L in is 0, then S in is also 0, so this entire term is 0. So what do I get? I basically get the product of the signs. If any one of them is 0, let me write this over here. Any L in is 0, then L out is what? So if any of the L ins is 0, then I have a 0 in this product, so therefore the result of the product is 0, and the arctan H of 0, well, there's only one point right there, the arctan H of 0 is 0, then L out is 0. If no L in is 0, then L out is equal to 2 arctan H, the product of the signs, which is equal to +infinity if the number of negative signs is even, and -infinity if the number of negative signs is odd.
+1.
No, I'm talking about after the arctan H. So
Right, yeah.
this will be +1 or -1. If it's +1, arctan H of that is +infinity, and if it's -1, arctan H of that is -infinity, and the 2 doesn't matter. So basically, this is, if we have time, we'll see an example of that. This is a quick way, it's a very neat and simple sum product algorithm in which the only possible values of the messages are infinity, 0, and -infinity. And basically, you're keeping track of how the constraints line up so as to fill in blanks in an erasure in a binary erasure channel. The final channel example that I want to deal with, and I regret that we haven't had a lot of time to talk about this because it's possibly the most fundamental channel in communications, is the, can I erase this?